Alright, so someone just sent me these questions here, and I have some free time, so let's give them a try. They're actually some differentiation problems, so yeah, not so difficult. So the first problem goes here: use logarithmic differentiation to find dy dx, the first derivative of this function here. So we have the function as y equals the square root of x squared minus 4 into x squared plus 7. Alright, and the question is specific. We have to use logarithmic differentiation. So we have to somehow apply natural logarithms, something like that. So there are several ways of doing this. Let me begin by squaring both sides. So we have y squared equals x squared, or that's going to be minus 4 into x squared plus 7. Okay, there we go. Then I'll apply natural logs on both sides. So the natural log of y squared equals the natural log of x squared minus 4 into x squared plus 7. There we go. So using the properties of logarithms, I'll just remind you here. So if you have log of a times b, that's the same as the log of a plus the log of b. So I'm going to use that to expand this quickly here. So this is going to be, just come down here. So that becomes log of y squared equals log of x squared minus 4 plus the log of x squared, okay, x squared plus 7. So now we can easily take derivatives on every term. So the derivative of this is going to be, that's 2y, okay, divided by y squared, dy dx, equals, here the derivative of this function is 2x, divided by the original function, of course, x squared minus 4, plus the derivative of this function here is, that's also 2x, okay, divided by the original function, x squared plus 7, and we're almost there. So I'll just remove a few terms here. This y cancels with one of the y's down here, and then you can see there is 2 everywhere, so I just divide all throughout by 2, and now I have dy dx equals, I'll just have y multiply this side, maybe times x, and then you just write this x like this, and then inside here we have 1 over x squared minus 4 plus 1 over x squared plus 7. I mean, I've factorized out the x here and here, this x, that's what we are having outside here. Okay, so lastly I have to replace for y, because we're finding the derivative of y with respect to x, so it's nice to have our answer written in terms of x. So finally our answer dy dx is going to be y, which is the square root of x squared minus 4 times x squared minus 7, plus 7, okay, all this times x times 1 over x squared minus 4 plus 1 over x squared plus 7. Okay, so there you have it. You could go ahead and see if this simplifies to something better, but I'll just stop it here for purposes of not making this video long. Okay, so let's go to the second problem. Find y prime, still first derivative, just using another notation, using implicit differentiation. So the function is given here. Let's just create a quick new page here. 10 x cubed y, okay, 10x cubed y squared minus x to power 4, what is that, minus x to power 4, okay, plus 5xy minus y cubed. So plus 5xy minus y cubed. Okay. Plus 10 equals to 0. So we want to use implicit differentiation to find the first derivative y prime for this function here. Okay, that's easy. Let's see. So we have 10 is a constant here. I'll just pull that out. I'll use product rule for these two. So the derivative of x cubed is 3x. Then I keep y squared constant. Plus the derivative of y squared is 2y times y prime. Of course, in that case, I keep x cubed constant, so to say. Okay, the derivative of, so I'm done with this. The derivative of x to power 4, obviously that's 4x cubed. Plus, I come to this, you see a product of two things here. So 5 is a constant, I'll just put that out. Oops. Okay, then I use product rule here. So the derivative of x is 1, I keep y constant, plus the derivative of y is y prime, I keep x constant, there we go, minus the derivative of y cubed, that's 3y squared, cos times y prime, and then the derivative of 10 is 0, the derivative of 0 is 0, so there we have it. Let's just do some simplification. So multiply this 10 inside, I have 30xy squared minus, plus 20y x cubed y prime minus 4x cubed plus 5y plus 5xy prime minus 3y squared y prime equals 0. So I will collect together the terms that have y prime in them. This term here, this term, and this. And I'll just factorize out y prime. So I have 20y x cubed. This guy comes next, plus 5x. And then this minus 3y squared equals, I take everything else to the right hand side. So I have 30xy squared minus 4x cubed plus 5y. That's okay. Yeah. So finally, y prime equals 30xy squared minus 4x cubed plus 5y. All this divided by 20. Okay, 20y x cubed plus 5x minus 3y squared. Alright, hope that's fine. So just go back to the previous page and see the third problem. Use logarithmic differentiation to find the first derivative for this function. Alright, y equals the log of 2x plus 1 cubed. So y equals the log of 2x plus 1 cubed. Now, you may know that if I have the log of a to the power b, this is the same as b times the log of a. So this problem is equally the same as writing it as y equals 3 times the log of 2x plus 1. And by the way, for starters, I should have mentioned, if you have y equals the natural log of some function of x, then the derivative of y with respect to x is given by the derivative of this function divided by the original function before taking the derivative. So let's do that here. So the derivative, the first derivative is 3 is a constant. I'll just leave that there. The derivative of 2x plus 1 is just 2 divided by the original function, which is 2x plus 1. So y prime is essentially 6, 3 times 2, divided by 2x plus 1. So there we go. Okay, I clear this up, go back to the previous page. Okay, so we have some integrals here. Integrate, so evaluate x times the exponent of x squared. Integrate x times the exponent of x squared dx. Well, so in this problem you can identify a composite function, which is this, and then if you look at this function that is inside here, x squared, its derivative involves x, so this suggests that we can use u sub, so I'm going to let u to be equal to x squared. Okay, so du dx is going to be 2x. That means dx is going to be, what's that? Du divided by 2x, which is nice because we are going to replace for this here. Okay, so I rewrite the integral again as the integral of x times exponent of u times, for dx I'll write du divided by 2x, and you can clearly see that this x cancels with this. So I have the integral of exponent u times du, which is really exponent u, plus the constant of integration. If I substitute back for u as x squared, I just have exponent x squared plus a constant. Right? Next problem. So I erase this and just go back to the previous page. Perform the integration. So we have 2x squared into x cubed plus 1 squared. Okay, let's see. Integral of 2x squared into, let's see, x cubed plus 1 squared. Okay. X cubed plus 1 squared dx. So again, you can see here we have a composite function here, and the derivative of whatever is inside this composite function will give us some x squared. So that's a nice thing, because in that case we can always use a substitution. So let u equal to, by the way, I have an extensive video where I talk about some tricks to use or to identify which integrals can be done using u-sub. I'll leave a link to that video in the description. You can check it out. So I'll let u to be equal to x cubed plus 1. So du dx is simply 3x. Okay, 3x squared. And of course dx is going to be du divided by 3x squared. So I write this integral again as the integral of 2x squared times u squared. Of course all this here is u. Instead of dx, I'll write du divided by 3x squared. So you can see that x squared nicely cancels out. I'll just pull out 2/3 as a constant. Then I have u squared here, du, which is basically, what's that? 2/3 u cubed. And then this is 1/3 here. Okay, u cubed divided by 3 plus a constant. Don't forget that. What was that? Yeah, plus a constant. So here I have 2/9 u cubed. I just substitute back for u, so that's 2/9. Our value of u is x cubed plus 1 cubed plus a constant of integration. Alright, so back to the previous page to see what we have next. Yeah, 2 more problems to go. So, just a moment. Alright, so yeah. Problem number 6, we have integral of x to the power half plus 1 to the power 4. So integral of x to the power half, x to the power 1/2 plus 1 to the power 4 times 1/x, x to the power 1/2. Is that so? Okay, dx. Of course, x to the power 1/2 is the same as root x. So that's it. And if we take the derivative of this function inside here, somehow its derivative will have 1/2 in it. Let me show you here. So if I let u to be x to the power 1/2, well, du dx is going to be x to the power 1/2 minus 1. Of course, I've got to first drop 1/2 here, so 1/2 minus 1. That's going to be 1/2 x to the power negative 1/2, because 1/2 minus 1 is negative 1/2, which is basically 1 over 2x to the power positive 1/2. Okay, so this is du dx. Okay, so I'll use this to substitute for dx here. Let's go ahead and say the integral of, so everything here is, let me just say plus 1. Of course, that does not change the derivative. Okay, nice. So this is u to the power 4 times, what's this here? 1 over x to the power 1/2. Okay, times, so for dx, let's see what we will have here. Yeah, that's going to be 2x to the power 1/2 times du. So you can see x to the power 1/2 nicely cancels out. This 2 here is a constant. I'll bring it out. So I have u to the power 4 du, which is 2u to the power 5 divided by 5 plus a constant of integration. So that's 2 over 5. Instead of u, I'll write x to the power 1/2, which is, by the way, root x. Just write that, plus 1 to the power 5 plus a constant. Okay, nice. Let's see the last problem here, number 7. Use exponential differentiation to find dy dx. Let's see the function here. Y equals the square root of 1 minus exponent x. Right, y equals the square root of 1 minus exponent x. Okay, so there are still lots of ways to do this. I mean, what should I do here? Let's just use, why don't we try chain rule here? Oh, by the way, the question has specific instructions here. We have to use exponential differentiation. I'm not really sure what exponential differentiation is, so I'll just do it any way I like. I'll introduce logs on both sides. So the log of y equals the log of 1 minus exponent x to the power 1/2. That's what the square root means. So natural log of y equals 1/2 times the log of 1 minus exponent x. Okay, so the derivative of this is 1 over y times y prime, or dy dx, whichever I like. 1/2 here is a constant. The derivative of this is, of course, the derivative of exponent x is exponent x. So, but there's a negative here, so that's negative exponent x divided by the original function 1 minus exponent x. So y prime is going to be y over 2 into exponent x divided by 1 minus, oh, that's a negative. Okay, I've just got to substitute back for y. So that's going to be, what's y? Y is actually this. So we have negative square root of 1 minus exponent x. This divided by 2 into negative, okay, I have this negative out already, I guess. Let me just write this like this in a much simpler way. That's going to be negative exponent x times the square root of 1 minus exponent x. That's this times this. All this divided by 2 into 1 minus exponent x. And I think this can be combined together with this to, just write it in a nicer way. So y prime equals negative exponent x over 2. So this is power 1, this is power 1/2. So that's going to be 1 minus exponent x to the power 3. No, that's going to be a minus up here. So that's going to be to the power negative 1/2. Okay, yeah, which I think I should have put down anyway. So that's the final answer. You can, go ahead to simplify that. Thanks for watching this video. If you find it helpful, give me a thumbs up, subscribe to the channel if you haven't, and if you have some problems you would want me to try out, just make sure they are not too hard for this channel. I've linked a form in the description where you can send me your questions, and if I have time I'll try them out. So thanks for watching. I'll see you next time. Bye.